Hello, I'm Michael Forrest, and today I'm starting an incredibly ambitious new project called RealtimeSwift, which will be a SwiftUI-style declarative rendering engine that will let me render out pixel buffers that I can send to my camera extension or over the network or into an editor in CueCam Presenter in the UI in a way that makes it easy to produce high quality results without breaking my brain trying to synchronize various different frameworks and state that's held in all sorts of different places. So if I can pull this off, it's going to be a very powerful and useful system, not just for CueCam Presenter, but for Shoot, Video Pencil, and anything else I might come up with in future. Some people say you should have a moat for your business, and I think this engine, could be a pretty huge moat for me once it's working. But I don't really feel like being super protective of this stuff, and I'd rather work in public. And I think it's going to be more fun if I can bring you along. And you never know, someone might tell me this has been done already and save me the bother. So, first question is, why not SwiftUI? Well, basically it won't give me decent pixel buffers we've got image renderer in SwiftUI. You can give it a view and say, give me a CG image, but this is kind of what you get. Here's a sort of testing view that I've got. And you see, it's a little bit wonky, but at the top there's the time is ticking up and we've got a little spinny thing, and then I've got like a video feed there. But if we kind of jump through to what SwiftUI image renderer gives me, basically this isn't animating because all the animation system is internal. This is actually not even updating, which there's probably a way to make that update. But then you just get this awful, as soon as you do anything with a drawing group or with a video render layer, or you've wrapped something in view representable or something like that, you just get this this kind of no thank you thing. And I've tried loads of different ideas. Can I sort of pull in the background layer? But I'm basically trying to turn whatever SwiftUI has given me into pixel buffers, and I just haven't managed to find a way. And so I'm going to tell you how I'm doing, I'll tell you about how CueCam is doing its rendering at the moment another time. But the basic problem is that there's various different systems that are impossible to synchronize well, and it's just become very hard to reason about because it's so imperative. So just TLDR, I've got some scene kit stuff, I've got some SwiftUI stuff, I've got some metal stuff, I've got shaders going here and there, and it's all kind of very multi-threaded and actor based, and it's just very hard to, basically it's become harder and harder to make changes to CueCam Presenter because there's just too much to think about with how it puts things on screen. So what is success going to look like? I basically want to be able to render my virtual camera iPad reference, so the thing that goes over to the iPad so I can see what I'm drawing on, which has to be different because it has to not include the the pencil drawing. I want to see my editor previews with the correct camera LUT and all that kind of thing. There's a lightbox overlay that comes in on your desktop when you're sharing your screen so you can sort of avoid covering stuff up. And I want it to look something like this. So the syntax that I'm thinking is, so basically real-time Z stack. So just basically like SwiftUI, and then set up my different layers. So pixel buffer layer with a source, different sources. I'll have my slides, with the current slide, and then the ability to have conditional stuff in. So here, say I've got a different picture-in-picture mode that I can have an enum, pass in the edge I want, and then just that picture-in-picture circle view will just kind of put that in the right place. And then all the transitions, the idea is all the transitions will just be handled, I'll have modifiers and things to set up transitions and stuff, but basically I want to just look at, this will be an observable, using the observable macro in Swift, and then changes on this will get sort of propagated down into here in the way that they do in SwiftUI. So here's where we're up to, and just let's make sure everything is looking nice and handy. So here's where I'm up to so far. So I've actually got this going. So I've made myself a real-time Z stack. I can layer in some different things. This isn't really doing anything yet. The slide layer doesn't do anything, but my testing layer is this text layer, which just takes the date of the presentation and just sticks that into a string. And so if I run this, or just show you it running, basically you can see this is the exciting view I've got. But this here is a metal view, and it's updating reactively. So you see this number is being rendered into a pixel buffer. It's ticking up reactively. And at the bottom, I've done a little kind of like a little tree visualizer, so I can see, you know, like kind of what I'm dealing with, and I can see sort of the time ticking up there in the same way as I'm seeing it, you know, in the view, just so I can sort of see. I'm going to start sort of comparing these different views to see what we've got. So in Xcode, I've created a new package called RealtimeSwift, and we'll sort of start looking at that. But first, I'll show you how the preview, how this little application I've just shown you, it's a little preview to sort of start testing. So that presentation preview is actually a view NS view representable around an MTK view. So this is sort of using my real-time hosting controller. Well, I'll show you that in a second, but I think what I need to show you here first is, so that view is, so it's taking a presentation preview and it's passing in this presentation, and then that presentation view is getting created with that presentation object. If we look at the presentation, we see that that is an observable, using, you know, Swift observable macro, and sorry, let me just get back to presentation. So this is here, it's observable, and I've got a start ticking function which just updates the date every second, just so that I can sort of have something that's changing. So this is where we make a call to the first sort of main thing in the package, which is this real-time hosting controller, which takes a root view. So much like UI hosting controller, it's kind of the same idea. And then so there's going to be some stuff hidden in this hosting controller that handles all the important stuff. So we pass in that presentation view, and this is not a SwiftUI view, this is a real-time view, which is from my framework, and real-time hosting controller is from my framework. So basically it's kind of like setting up a timer to render like 30, yeah, so it's like 30 frames a second just for testing. So like the webcam will be 30 frames a second. So that's kind of what I'm looking at. So unlike SwiftUI, which sort of needs to render at 120 frames a second and do all that kind of fancy stuff, I'm generally locked to a specific frame rate, or I'm sending it over the network because I'm doing like camera stuff. I'm not really doing like UI stuff with this. So basically, each frame, it just gets an image back from the render function in controller, and then I'm sort of doing this little debug view. That's how it's drawing that other thing. So here's where we first jump into the package. We have got a real-time hosting controller, which it doesn't do very much yet. The basic idea is it takes in the root view, and then each time, so here's how it uses that Swift observable thing. So it just goes with observation tracking, just sort of like call resolve on that root view's body. So it just kind of extracts out the render tree from the body by executing those bodies, and which I'll get into later. But for now, it basically just sort of like each time something changes, it updates this latest frame, and then that's all that's really being. At the moment, I'm just returning latest frame from the render function. I'm not really doing anything else. But yeah, the important let me just sort of step back before I go any further with that and kind of talk about how this is going to work. So with SwiftUI, you're declaring a struct, which is code that is the state of the view. So you might have like you might have like an H stack. Let's go to a sharper pen, and then we might have a text, and we might have a like a color, right? And so each time we create these view structs, and these are basically disposable things, and we're throwing these little views over to our renderer, so to SwiftUI, but in our case it's going to be to RealtimeKit. So I'm going to do this in the controller, right? So we're just going to go, okay, the state, here is the view that is going to be sent over as a struct to the controller. and that's, you know, I don't want to like reuse other people's analogies, but it's a throwaway thing that's basically a blueprint for the state. But the first time it gets that model, and then each time it sees a change, it kind of goes back and re-renders that thing and sort of updates what we're maintaining here, which is, okay, so if there's a conditional thing here, I'm not explaining this very well. There's a book on objc.io that explains it much better than I ever can. But let me just try and, I should have written this all down. We have a view struct with the current state of the view. Whenever the observable model changes, the view's body will be executed again. And this is managed by the engine. So we call the view's body for each nested view and build a render tree. So we get this view code, right? This is like code, right, with the view declaration. We execute that to create the render tree, right? So then that's like, is there a text box? Is there an H stack? What's in there? And then whenever the model changes, then we re-execute this code, and we might get now like a different render view. And then basically the engine is responsible for going, okay, well, how do I turn this into this? And this, you know, this is then holding on to like textures and objects and different things so that it can like internally kind of manage the transition between the two things. Sorry, not very clear. And hopefully over the coming episodes, well, once we start to see it in code, it might make a bit more sense. But you can see, like, I'm sort of getting my head around this by doing it. So, you know, that's kind of where I'm up to. So the first challenge here is to implement and deal with our own result builder that lets us declare views and, you know, nest views in the same way as SwiftUI. So let's have a look at our real-time view. So this has got we've got a real-time view, and then we've got this real-time view builder body function, right? So that's the thing that lets us sort of not have to return an array or anything weird like that. And so a real-time view builder is implemented here, and basically this it's a result builder, and it kind of needs these 4 functions, which honestly, like, I'm looking at this, I got a bit of help from AI, but the bit that really kind of confused me to start with was this the build block that returns. It does this repeat each content. So basically, if you give it multiple, you know, an H stack of text and different, you know, a sequence of different things, it's able to kind of use this repeat each syntax to extract the classes, the types of each one of those things, and then turn it into a great big tuple, which is initialized with this kind of value thing here, just to hold it. But basically, so this creates a static type based on the code that you've on the declaration that you've made on the nested stuff in there, the H stack, you know, contents, you know, but it's just sort of like, I did this, you know, in the old days of Swift, there was like 10 overloads, so you could have a maximum of 10 things, but this repeat each is the way that they've kind of like overcome that and made that unlimited. But, you know, how do you actually, you can't really iterate over the type without sort of jumping through some hoops. So in this file, you know, you can also see I've started some primitive types as well. So I've got like, below the tuple real-time view, I've got this like real-time Z stack, which is, you know, again, like just implements that real-time view. I've actually got a primitive real-time view thing that just says don't return a body, and we'll kind of get into that later. But yeah, I've just made a pixel buffer layer that takes that, and then we've got a text layer that takes a text string and sort of stores it, and that conforms to primitive real-time view. So once we've we construct the view hierarchy, basically using this the result builder and those different types that we have here, and then obviously like each of these types will have whatever it needs to instantiate itself. So then we're basically, to create that render tree, I'm calling this resolve function. So I'm extending real-time view with this resolve function, which basically returns a render node, which is something that we can then use to render views. But basically, really it's a sort of placeholder for the structure that, as it currently is, so that it can be compared to the next structure. And this is where we get a little bit tricky. So we look at the body type, the type of body, and if it's not supposed to be, so if it is something that has nested stuff in it, then we recurse into the body, into the new body type, and kind of like resolve that the body that's in there. But if we're on a point that we can do something with it, we're going to either conform to leaf renderable view. So actually, like the stuff that conforms to leaf renderable is like the text node or like a pixel buffer node, which is like, okay, this is kind of at the edge of the tree, and it's gonna be, you know, we can sort of like draw some text with it. So basically we extend text layer with leaf renderable view. This resolve function now returns a specific type of render layer text layer node, which takes that text in and then is able to kind of like render an image accordingly. And this is just like a really basic, like stick some stuff on screen. The container thing isn't really, I haven't really done anything with yet, but it's going to be for stuff like for each that does take an explicit array or collection of things that works in a more normal way. But the tricky part is this tuple view. So at any time we have one of those, then we need to turn these back into some sort of collection that we can iterate over. So there's this protocol that we've implemented called type erased. So if it conforms to type erased container resolver, then we call the erased resolve rather than the resolve on there. So what do I mean by that? So this is just another protocol, type erased container resolver, so that we know that we've got that erased resolve from that type comparison. And then inside, then we conform our tuple real-time view, which you remember was created from that result builder, to that type erased container resolver, and then we can basically use mirror, reflecting value that's in there, and now we've got the children and we can enumerate over them. And I'm actually like, there's some stuff with identity that I'm going to get into later, which I don't fully know how I'm going to do it yet, but I'm basically like using the position to determine the identity of the views. So we're just kind of iterating over that, and then we know each of those children is a real-time view, and then we can call resolve on each of those children, right? And so now this might be a text, this might be a pixel buffer layer, this might be a nested Z stack or something, but we can just resolve that subview. And then once we've got those children, we can just return this resolved tuple contents and just pass the children through to that. So this is basically just a store for an array. It's basically, we've turned our typed tuple into an array of render nodes now, and then that's going to be something that we can now work with. So then when, this is the Z stack, so this is a view that has a collection of subviews in here. When we have resolve, we're going to say, okay, Z stacks have to be constructed using this view builder, so they're going to conform to this resolved, when we resolve the content, it's going to conform to this resolved tuple contents, right? It's not going to be like just a straight up view. If not, then I've done something wrong. So there's some fatal errors in there for me, just so that I know I've done something wrong, that hopefully the user never comes across this. And then once we've got that resolved tuple, we can just grab its children and just make this render node, which just takes an array of children. So here, ZStack render node, we take the children as an array of nodes, and then just to create an image or something, we just kind of iterate over that, and I'm just doing like an CI image composited over, and that's step one. So this is what that looks like, right? So we've just got, we've got in our, well, if I go back, yeah, so here's the, we've got real-time ZStack. And basically all that's really rendering at the moment, the only thing that really has an image return is this text layer. It's watching changes to that presentation date and just formatting it into the text layer. And then here you can see that it's picking up changes in the model down here. And this is just like ticking away. And so you can see it's basically working. So, and then there's this visualization down that bottom that I won't go into too much because I basically got ChatGPT to help me do something. But basically, I've separated it out from the rest of the stuff, so because I don't want SwiftUI in any of the other stuff. It's just basically doing some positioning. It's using HStacks to position some nodes and then sort of like awkwardly kind of drawing lines in there. But yeah, just I wanted to be able to visualize what I was looking at all times and not just like get confused straight away. So yeah, that's kind of where I'm up to. So it was pretty exciting today it's something I've been thinking about for a while. It was pretty exciting today to actually go from I'm declaring a view struct hierarchy and then getting something on screen. So there's obviously a lot to do. So let's see, what's next is like layout, obviously. So I'm looking at a minimal and less flexible version of what SwiftUI offers, but basically kind of following some of those principles, but I'll probably add the stuff as I need it. But to be honest, because I have slides, the slides are quite flexible in CueCam, so I'm probably going to have to implement quite a lot of that layout code just to be able to kind of put text above other text, the way it's rendered. So CueCam is rendering this stuff using SwiftUI and then turning it into metal textures. So then I kind of want to be able to a source registry of pixel buffer sources. So I want to be able to declare layers by name, just like that, and then just it can figure out which camera I mean, which screen share, fire up the capture as and when needed. But I just don't want to think about that at render time, basically. Transitions, obviously, we've got to be able to move things from one place to another, and that's going to be a huge win once I can get that in. We've got to think about typography a lot, and then obviously like modifiers I need to figure out probably sooner rather than later, just because I don't really know how I'm going to do that yet, and where they get, modifiers, environment, all that kind of thing that I still basically need to figure out. But, that's where we are. So thank you for watching. I hope you found that interesting and that you will like and subscribe for more. And so this video was created using CueCam Presenter, and I'm just going to show you what my script looked like by going into here. So if it should be letting me show you the script. So you see, like, to run through all this. I basically put all this together in CueCam Presenter. I brought in videos to sort of like play the right thing. I'm jumping to specific lines of code as I go. I've got this all up on screen to read it. So yeah, you can get cuecam.app, and so I hope you will subscribe again and give the app a try at some point if that's something that you think might be useful for making demos like this. All right, take care, bye.